Hello students, I am Professor Rutuja Kadam from Symbiosis Institute of Technology. Today I will be covering one important topic in operating systems memory management chapter, compaction techniques. So let us start with compaction techniques.
Good morning students. Today I'll be starting with compaction techniques. Now before starting with compaction techniques, let us look into the basics of memory partitioning. There are basically two types of memory partitioning. One is static memory partitioning. The second one is dynamic memory partitioning. In today's video, we will be concentrating on dynamic memory partitioning. Now, what do you mean by dynamic memory partitioning? We will see it later on. But a gist of it is drawback. One of the drawback of dynamic memory partitioning is external fragmentation. And the solution of external fragmentation is compaction techniques. So this is why we are learning compaction techniques. Now slowly we will go into the details. Now let us see first what is dynamic memory partitioning. Now here dynamic memory partitioning is the process wherein each process is allocated a space as per its requirement. So here if you can see, process is allocated space in memory based on the process's requirement, or we can say based on its size. So here there is a diagram which depicts how dynamic memory partitioning works. So let's say this is the initial partitioning of the memory whose size is 128 MB. Now what happens? Initially the operating system is loaded. Now let us say the size of operating system is 32 MB. The free space available is 96 MB. Now, in the second diagram, process P1 comes. The size of process P1 is 24 MB. So, here 24 MB is allocated to process P1 dynamically as per its process size. In the third picture, if you see, second process comes whose size is 32 MB, which is again dynamic, which is not fixed. So after 24 MB, 32 MB is allocated in the memory for process P2. After that P3 comes, whose size is 38 MB and that is allocated in the memory. Now if you see, if you total this 32, 24, 30, 32 and 38, it becomes 126 and the initial memory is of what size? 128 MB. So out of 128 MB, 2 MB is free. Now if this 2 MB is free. So here the disadvantage of dynamic memory partitioning is that this 2 MB space, which is very small in size and not a single process can fit into it and can execute itself. So this space remains unutilized. This particular concept is called as external fragmentation. So to overcome the problem of external fragmentation, the solution was developed which is called as compaction. Now let us see what is compaction. As I have told earlier, the free spaces such as 2 MB in the earlier diagram, in that space not a single process can execute itself and that space remains unutilized. So in compaction what happens is that such free spaces in the memory are compacted together, or we can say they are combined together to form a new partition so that some other process can execute itself into it and that free space is utilized. So that is compaction. So here if you see the definition, compaction is the technique wherein all free space is compacted or combined together to form a new partition or block so that some other process can utilize it. Now the problem with this compaction technique is to fit the process of n size into partition of n size. As the size of the process is variable, similarly the size of the partition is variable. So how to fit this n size process into n size partition? For that we have three methods to search for the partitions. The three methods are first fit, best fit and worst fit. Now we will see all the three concepts in detail, and we have to solve a problem based on this. So let us see the example of this. So this type of example is asked or can come for compaction techniques, wherein consider a swapping system in which memory consists of the following whole size or partition size in memory order as 10 KB, 4 KB, 20 KB, 18 KB, 7 KB, 9 KB, 12 KB, 15 KB. So this is how it is represented. These are the partitions available. Now using different methods. So which are the different methods? First fit, best fit and worst fit. Find out partition is selected for successive request. Now the request that have come is for 12 KB, 10 KB and 9 KB. So we have to find the spaces for this particular size of the process to get fitted into this particular memory holes. Now we have to do that with the three methods: first fit, best fit and worst fit. So let us start with the solution. Now what is first fit? Here if you can see this initial memory spaces, I have drawn that. Now we have to find the space for 12 KB, 10 KB and 9 KB. So in first fit algorithm, what happens is that the largest memory hole or the largest memory space is first find out, and that particular request accommodates itself into that particular space. So here if we sequentially search the memory partitions, and which is the first highest hole found over here sequentially. So after for 12 KB, is the 10 KB highest? No. 4 KB? No. Then comes 20 KB? Yes. So here we can definitely accommodate 12 KB. So if you can see, this 20 KB is divided into 12 KB and 8 KB, wherein this 12 KB is allocated over here. Then for 10 KB, we again search sequentially. So here again the first slot itself we found out as 10 KB, so that also gets used. For 9 KB, if you see, if we go in a sequential manner, 10 KB is already utilized, 4 KB is smaller than 9 KB, 20 KB was divided into 12 and 8, out of which 12 was used, 8 is smaller than 9 KB. Then let us move to the next one, that is 18 KB. Now that can be utilized. Here 18 will be divided into two parts, that is 9 KB and 9 KB, out of which 9 will be utilized. So this is first fit solution. In best fit method, it allocates the smallest hole that is big enough in the entire list, or in the entire list of available partitions, and it is searched in order. So for example, let us say we have to find a space for 12 KB in this memory partitioning which is available. So what will happen? First it will search the entire list whether it finds the 12 KB slot into the memory directly. So here if we check 12 KB slot is available, so directly it is utilized. But then if 12 KB slot was not directly available in the memory allocation, so what would have been done? So here let us now consider that 12 kb is not available. So what is available? 10, 4, 20, 18, 7, 9 and 15. So here, 12 is not available. So after 9 directly 15. So we will search the entire list. Try to find out the minimum gap between the partitions. So 10 is smaller than 12, so no use. 4 is smaller, no use. 20 the difference between 12 and 20 is how much? 8. 12 and 18 is 6. 7 smaller, 9 smaller. 12 is not available in this scenario. Now consider 15. Difference is 3. So here 8, 6 and 3. So which is the smallest one? Smallest difference? 3 kb. So that particular hole will be allocated to 12 kb. Similarly here, now let us go to the 10 kb. If we search the list, 12 kb slot is directly available. Then we will go for 9 kb. For 9 kb, we will search the entire list. Let us first check whether 9 kb slot is directly available. Yes, it is available. So we will utilize it. So this is best fit. In worst, now let us go to the worst fit algorithm. In worst fit, it allocates the largest hole. It searches in the entire list for the largest hole. Now, for the first request, that is 12 kb, how we will do that? So initially we had what? 10 kb, 4 kb, 20 kb, 18, 7, 9, 12 and 15. So first comes what? 12 kb. So out of 10, 4, 20, 18, 7, 9, 12, 15, which one is the largest? The largest one is the 20 kb. So that particular hole will be selected for 12 kb to be allocated. So here this 20 kb is divided into 12 and 8, wherein 12 will be allocated. Now comes 10 kb. After 20, which one is the largest hole? The largest hole is 18 kb. So that will be selected now for allocation. So here if you can see this 12, 8. After that 18 will be divided into 10 and 8, where 10 kb is allocated. After that move to the 9 kb request. So here again which after 20, after 18, which one is the largest hole? 15 kb. So this 15 kb will be selected for allocation of 9 kb. So here if we move, you can see 9 kb is allocated. Out of 15, 9 is allocated, 6 is unutilized. So this is worst fit method. I hope everybody understood this.